Exercise 3G, projectile motion. So Ji Ming, the golfer, hits a ball from ground level down here with initial speed of 50 meters per second and an initial angle of elevation of 45 degrees. And the ball, so the ball hits, so for example, the ball hits here. I might do it in two colors, okay? And rebounds off an advertising board 75 meters away. So I'm going to draw it myself, okay? So we've got, this is what we've got. The ball leaves at 50 meters per second at an angle of, wasn't it 45 degrees? It then hits a board, so we've got this advertising board over here, which is 75 meters away. So that tells you that x is 75. So the particle will, you know, that's the initial velocity, but the particle drops off. It'll hit here. So that's your forward motion. So it'll hit there. Then it rebounds. And when it rebounds, they've got it coming back like this. And the rebound is in red. I'll just, yeah. And the rebound comes back like this in red. Okay? So the forward one is the black. We have it off like that because the particle won't always stay at that angle. Do you know what I mean? It's just initially at 45 degrees, then you've got gravity acting on it, so then the particle will go lower. Does that make sense? That's the initial trajectory path, but then it'll go down lower because you've got gravity acting on it. Now, it says, and this is 75 meters, and G, which is the acceleration in the vertical direction, 10 meters per second. Of course, that's acting downwards, so it's negative 10. So it says, show that the ball hits the boarding after 3 on 2 root 2 seconds at a point 52.5 meters high. Now, before we do that, we need our, what? 6 equations. We need to do our 6 equations. So we're going to start with our right angle triangle. So girls, they'll ask you normally to derive the equations of motion, or they will give you the equations of motion, okay? So let's draw our right angle triangle to start with, and that's always the initial velocity in that right angle triangle. So we've got 45 degrees. What was the initial velocity? 50 meters per second. So we've got x dot and y dot. Remember, this triangle is for initial velocities only. So what have we got? So I'm going to do just initial velocities first. Initial velocities. Let's go. What do we do with the 45? Sine and? I need to work out x dot and I need to work out y dot. So I go sine of 45 degrees is y dot on 50. So y dot is 50 sine 45, which is 50 times 1 on root 2, which is 50 on root 2. That's your initial velocity in the vertical direction. And then we've got cos of 45 is x dot on 50. X dot is 50 sine 45, which is also 50 times 1 on root 2, which is 50 on root 2. I'm just going to leave it like that rather than, oh, actually, why don't we write it as, isn't that, what's that? Sorry, yes, it is cos. So girls, let's, that's cos. Can we actually write that without the root 2 in the denominator? Because it'll get a bit messy. So what do we do? Isn't that 50 root 2 on 2? Don't we times by root 2 on root 2 to rationalize it? So what do we get? 50 on root 2 times root 2 on root 2, which is what? 50 root 2 on 2, which is, anyone? 50 root 2 on 2, which is what? Simplify. 25 root 2. So therefore this one's also 25 root 2. So they're both, that's much better and easier to work with than 50 on root 2. So 50 on root 2 is the same as 50 on root 2 times root 2 on root 2, which is 25 root 2 for both. But let's derive let's look at our horizontal motion now. And then we're going to look at our vertical motion. What do we start with to do horizontal motion? Yeah, acceleration in the horizontal direction equals 0. That's our first equation. Next, do you remember what to do, girls? Velocity in the horizontal direction is the integral of 0 dt, which is c. 1. What do we do now? When t equals 0, what do we know? X dot is 25 root 2. So therefore x dot equals, therefore C1 equals 25 root 2. Therefore x dot equals 25 root 2. Are we good? Now what do we do? X is the integral of 25 root 2 dt, which is, then we're going to do vertical motion. What do you get? 25 root 2t plus c. Do we know anything about initial conditions of x, and where does the particle start from here? When, no, initially, when t is 0, x is 0. Yes, t is 0, x is 0. So when t is 0, x is 0, so what do we end up with? That's C2, by the way. What does C2 therefore equal? We get 0 and 0. Therefore, C2 is 0. So therefore, x equals 25 root 2t. So we've got, you might want to box up your equations so that you can see them. I don't think you're going to need the... And then we're going to start with vertical motion, same thing. All good? Vertical motion, y double dot equals negative 10. Please put the negative 10, because it's acting downwards. Even though they say take g to equal 10 meters per second, you need to say that the vertical acceleration is negative 10 because it's acting downwards. So what do we get? Y dot equals integral of negative 10 dt, which is what? T plus c. Oh, is it a bit? Come on. When t equals 0, y dot equals, I did it before, look at 25 root 2. So therefore 25 root 2 equals 0 plus c, therefore c equals 25 root 2. Girls, please be careful when you're working out your c, because in the last task, some people have to, you just got to make sure that you solve properly. If the 25 root 2 was here, it would be negative, like you'd have to take it to the other side. Just be careful when you're doing it. That's positive. So therefore, y dot equals negative 10t plus 25 root 2. That's velocity in the vertical direction. So I'll box that one up because you're going to use that. Now, y equals, what are we doing now? Integral of negative 10t plus 25 root 2 dt, which is, try not to write it as negative 10t squared on 2, just simplify it straight away. What do you get? Negative 5t squared plus 25 root 2t plus, so that last one was C3, we're now up to C4. Any initial conditions? When t equals 0, what does y equal? Yep, because it starts at the origin. So therefore 0 equals 0 plus C4, which means that C4 is 0. I mean, you don't have to put negative 0. So therefore y equals negative 5t squared plus 25 root 2t. So negative 5t squared plus 25 root 2t. Now we're going to answer our questions now that we've got all our equations of motion. Girls, the question is to show that the ball hits the boarding after 3 on 2 root 2 seconds at a point 52.5 meters high. Tell me what you know about where it hits the boarding.
When x is 75.
Yeah, so it hits the boarding, this is all we know, when x is 75. So we're going to substitute x is 75 into our equation for horizontal displacement. That will give me a time. Great. Okay, let's go. So, part A. We're going to substitute x equals 75 to find t. And we get 75 equals 25 root 2t. So therefore t is 75 divided by 25 root 2. Are we good with that? Which is 3 over root 2. And what do we do with that?
Isn't it 3 on 2 root 2?
Yeah, so we multiply that by root 2 on root 2, which is, so girls, that is it's got an irrational, so we've got 3 on root 2, but we need to rationalise the denominator, so we times by root 2 on root 2, and we get 3 root 2 on 2 seconds as required. But we still haven't worked out how high it hits. What do we do now? Sub that into y. So sub t equals 3 root 2 on 2 into the y equation. And we get y equals -5, 3 root 2 on 2 squared plus 25 root 2 times 3 root 2 on 2. All right, you can... Girls, I wouldn't be doing this on my calculator. You're going to need exact times. So we've got -5 times what? Isn't it -5 times 9? Times 2? You okay with that? What's 3 root 2 squared? It's 9 times 2. It's 18. So you've got -5 times 18 over 4. You okay with that? Plus, if you do 25 root 2 times 3 root 2, don't you get 75 times root 2 times root 2 is 2 over 2. So what have we got? Now you might want it. That's -5 times 9 over 2. It's -45 on 2 plus 75. Now you might want to use your calc. -22.5 plus 75. 75 minus 22.5, something like 52.5. I don't know. Yes, 52.5 meters high. Okay. So girls, show that the speed of the ball when it strikes the boarding is 5 root 58 meters per second at an angle of elevation alpha to the horizontal, where that alpha is 10 to the minus 1 of 2/5 is the angle. Yeah, and the velocity one. So we're going to go into the velocity equation, and we want the speed of the ball when it strikes the boarding. Now, we've got 2 velocity equations, remember? Velocity has, if we look up here, these are our initial velocities. So at any time, you've got 2 components of velocity, a horizontal and a vertical component of velocity. If we look at our velocity equations, this is the horizontal component of velocity, 25 root 2. Is that constant? Yeah. That never changes. But the vertical component does change. So we need to do a velocity triangle, because that's going to give us our angle as well at that particular point. So I'm just going to rewrite my velocity equations. We've got x dot equals 25 root 2. We've got y dot equals -10t plus 25 root 2. And we need it at a particular time when the ball strikes the boarding. Now we know the time when the ball strikes the boarding. So we sub t equals 3 root 2 on 2 seconds. And then we're going to draw our triangle. Okay? Now the ball does strike, if we look at our picture, the ball is striking, still it's coming up at that angle. So I'm going to draw a triangle here. That's the ball, and it's going to be striking the boarding. I've got x dot and y dot. Okay? and I'm going to need to work out the speed. So girls, with speed, with projectiles, you need the two components. You work them out individually, and you use Pythagoras' theorem to work out the speed, because the speed is made up of a horizontal and a vertical component. Whereas distances are different. You've either got the horizontal distance or the vertical distance. Okay? But with speed, you always need the two components. So what have we got? So that x dot is 25 root 2, but the y dot is going to, we have to work out what it is. It's negative 10 times 3 root 2 on 2 plus 25 root 2, which is what? Have I got negative 15 root 2 plus 25 root 2? Can you see that? Negative 30 root 2 on 2 is negative 15 root 2 plus 25 root 2, which is 10 root 2. So this y dot is 10 root 2. Are we okay? At this time, yeah. See, show that the speed v of the ball when it strikes the boarding. When the ball strikes, it's at t equals 3 root 2 on 2 seconds. Okay, and we need the angle too in a minute. So how do I do? Remember, velocity is made up of the horizontal and the vertical component. So therefore, velocity is v, we can do v squared equals, so v squared is 25 root 2 squared plus 10 root 2 squared, which is what? 25 squared, 625 times 2, 1250, plus 100 times 2, 200. So v is the square root of 1450, which is, now, see girls, they're saying show that it's that. What are you going to see? Which number? You're hoping what number goes into it? 25. So divide your number by 25 and let's hope you get 58. All right, so 1450 divided by 25, anyone? Root 58, which is meters per second. That's your velocity. Good. You need the angle. I'll do it in here. Yep, tan. Tan of alpha is, isn't it just 10 root 2 over 25 root 2, which happens to be, I think, 2/5. So therefore, alpha is tan to the minus 1 of 2/5. They just don't want you to work it out, otherwise you'll end up with a rounded off answer. So if you were to work it out, I don't know what you get, 0.4, tan to the minus 1 of 0.4. I think it's less than 45 degrees, because tan of 45 is 1. Anyone want to work it out anyway, so we get an idea? I mean, you don't have to for this question, but 21 degrees. Shift tan, 0.4.
48.
So it's closest to approximately, I'm going to go approximately 22 degrees. So in other words, the angle that it's hitting it at, if you look at that angle to the horizontal, is 22 degrees. Okay, assuming that the ball rebounds off the boarding at an angle of elevation alpha, sounds like it. Well, with the speed 20% of v. Oh, girls, with physics, does it hit, is the rebound angle, they're saying the rebound angle is the same as the angle of inclination. Okay, all right, assuming that the ball hits, oh, okay, got it, hits, rebounds off the boarding at an angle of elevation alpha. It looks like the same angle. With the speed 20% of v, find how far from G Ming that the ball stands. So we want this distance here, but I think we're going to have to find this first. So let's just 1 sec. Girls, but this is how the ball comes back. So they're saying, I'm going to put a dotted line here, that this angle in here is alpha. All right? So how does the ball come back? I'll draw the diagram again. So the ball, here's the wall, and we know the ball rebounds back like that, doesn't it? So if I'm going to draw a velocity triangle, are they talking all about velocity here? Because the only place you work out the alpha is with the velocity triangle, unless we've got a Cartesian equation. But we don't. So, and 20% of V. So you can work out 20% of the initial speed, what it is.
Is V
Or is it V, wait a sec, or is it 20% of V at that point when it hit? I think it's 20%, I know what it is.
go to B?
Girls, I think we need to go to part B. I think it's 20% of the 5 root 58. I think they need to be more specific. Do you want to?
I thought V was an
No, show that the speed V of the ball when it strikes the boarding. Okay? Yeah. So it's 20% of the 5 root 58. Now, they should look in the HSC to make sure that there's no confusion. That gets read over again and again, and it would be specific that it should hit it. It rebounds with 20% of the speed at which it hits the board. It needs to be specific so that you know whether it is at 20% of the 5 root 58 or is it 20% of the initial. It sounds to me like it's 20% of the speed at which it hits the board. It makes sense that it would be that. But in a HSC question, they should be very clear about that. This is what we've got here. The ball comes back like this. They're saying it rebounds at an angle alpha, which is, we know that alpha is tan to the minus 1 of 2/5. We're trying to work out that speed. Again, we've got an x dot and we've got a y dot. Now, and what's V equal to? Isn't it 20% of, which is 1/5 of 5 root 58? 20% is 1/5 of 5 root 58, which is root 58 meters per second. So we've got a right angle triangle with the hypotenuse root 58. On its forward motion, velocity is basically in that direction. Now velocity is coming back this way. The particle's moving back that way, yeah. So that's why we draw the triangle on the way back this way.
Yeah.
Okay? At an angle of alpha to the horizontal, it said. So find how far from G Ming the ball lands. New direction of motion, new everything, new 6 equations. X double dot equals 0. But you know, we're going backwards. No.
So it's the same.
All right, so what do we got? X dot equals? All right. Oh no, this is going to be painful. Tan to the minus 1 of 2/5. Really painful. I'm going to just put it up.
Can we just skip C?
No. Yep. No, it'll be good for you. All right, X dot equals, what do we got? We haven't worked them out. Let's do them. Cos, see, I'm just seeing how you're going to do this. Cos of tan to the minus 1 of 2/5 equals
Can I put that in our
X dot on, you probably could, equals X dot on, I'll just show you how to do it in a minute, on root 58. Now, but girls, if I draw the right angle triangle, isn't tan to the minus 1 of 2/5, instead of doing that, isn't it 2 over 5? And so therefore, just find the hypotenuse, which will be the square root of, girls, if tan to the minus 1 of, if the angle alpha is tan to the minus 1 of 2/5, you can write that tan of alpha is 2/5, you can work out the hypotenuse. What is it? Square root of 2 squared plus 5 squared, square root of 29. So therefore, it's cos of,
root 29.
cos, no, so it becomes cos of that angle. One sec.
Didn't we say it was like 21 degrees?
Cos of this angle. What's cos of that angle? Girls, what's cos of that angle? Isn't it 5 on root 29? Yeah, cos of this angle.
Oh, I get it.
Yeah, cos of alpha. We're doing cos of alpha. Cos of alpha. Aren't we doing cos of alpha? Doesn't alpha equal tan to the minus 1 of... Girls, we really want cos of alpha, don't we? Cos of alpha. Do you want me to put alpha in instead? I think it's more confusing like that. But we know that alpha equals tan to the minus 1 of 2/5, which means that tan of alpha is 2/5. So if you draw that triangle, I do want to do cos of alpha. I'm trying to do, look, wouldn't I normally go cos of alpha? Sorry, I know what's confusing you here. That's that. I need another triangle. I know what's confusing you now. Then I've got my x dot and my y dot. I can see what's confusing you. All right? I need one triangle to work out my alpha stuff. One triangle for the velocity. Got it? Yeah, that's what I did wrong. Okay, because that is not the horizontal velocity and that's not the vertical. That's just showing me what alpha is. So if tan of alpha is 2/5, I'm just drawing a triangle for my alpha. This is the square root of 2 squared plus 5 squared, which is the square root of 29. So therefore, girls, what's cos of alpha? 5 over root 29 equals x dot on, so back over here. That's my velocity triangle, back here. Actually, I've got that triangle. There's that triangle. So girls, this triangle helps me work out the alpha because I didn't have an exact value before. That's my triangle to work out alpha, what cos alpha is and what sine alpha will be. That's my velocity triangle, my new initial velocity triangle, where the hypotenuse is root 58 now. So I go cos of alpha. Now cos of alpha, according to this, is 5 on root 29. So cos on alpha is x dot on root 58. Are we okay now? So therefore, sorry about the mess, x dot is 5 root 58 over root 29. Girls, what can I do with the root 58 on root 29? 5. How does that look? What do you get? I know that you can't square root either, but you can do them, put them under the one square root sign. Square root of a over square root of b is the square root of a over b. What do I get? 5 root 2. So that's my x dot. So x dot is the integral of 0 dt, which equals c1. When t is 0, c1 is 5 root 2. Therefore, x dot is 5 root 2. Displacement while we're here. So x equals integral of 5 root 2 dt, which is 5 root 2 t plus c. Actually, our 75 comes in now. So what have we got? So girls, do you know what we're doing? We're coming back. When t is 0, what's x?
75.
Yeah, x is 75. Now we're taking the 75 into account. Just a hope.
Well, these do you take into
And we know that we're going to go backwards. If you put 75, that's really related to the other one. Just put when x is 0, just have a new starting point because it'll be easier. You know why I don't want to put 75? Because my displacement is not negative. And I know I'm coming back. Does that?
Yeah, it's positive and then it'll become negative.
Yeah, no. But just put when this is my new starting point. So every time we start again, we should have, I'm doing a new set of equations. So I need to start with t is 0, x is 0. But my height won't be 0 when I start. I know what that height is. So now I know I'm working backwards, but I'm going to take this as my new 0 position for horizontal. All right? When t is, because you know why I'm doing that? Because if my x would have come out negative, I would have felt more comfortable with the 75, but it's not. I can't go adding 5 root 2t to 75 because the particle will just keep going further to the right. It won't come back. Does that make sense?
There's displacement.
Yes, I know, but look at x. I know. Yeah, but you can get negative for displacement, meaning it's going backwards. But this will never be negative, this displacement. So if I put x is 75, the particle's just going to keep travelling to the right. So that's what we don't want happening. So when t is 0, x is 0, therefore we get c, that will be c2, is 0. Therefore x equals 5 root 2t. Now, they're my horizontal equations. See, girls, if you've got a diagram, if you've got your diagram when you're interpreting later, it will help you. We're going to do the same thing here now for sine with that triangle. You know how we had cos alpha? We're now doing sine alpha. Do you know what we're doing? Sine alpha is what? From the... Girls, what's sine? I need to do my vertical component of velocity. Sine alpha is y dot on root 58. What does sine alpha equal from this triangle? Sine alpha.
2 on root 29.
Yeah. 2 on root 29 equals y dot on root 58. So therefore y dot is, I think it's the same, 2 root 58 on root 29, which is, no, not quite the same, 2 root 2. Got the idea? Meters per second. So now we've got to come back and finish off. Are we okay? Sorry girls, I know it's a bit challenging. All right, so we've got our horizontals. Let's go with our verticals. Y double dot equals negative 10. Y dot is the integral of negative 10 dt, which is negative 10t plus c. When t is 0, y dot is that, 2 root 2. So therefore 2 root 2 is 0 plus c. C is 2 root 2, isn't it? So therefore y dot equals negative 10t plus 2 root 2. Oh, over here, sine alpha, that same equation, the same triangle. So girls, I'll just keep going. So y is the integral of that, which is negative 5t squared plus 2 root 2t plus c4.
So is y 0?
No.
Because it's initial.
Yeah, but I know it's the initial, but it's starting up high. So when t is 0, girls, y is 58.5? 52.5. So therefore, 52.5 equals 0 plus 0 plus c4. That means c4 is 52.5. Therefore, y equals negative 5t squared plus 2 root 2t plus 52.5. Now, once you've got that, what's the question? How far from G Ming the ball lands? So girls, the ball comes back and hits the ground. What do you know about when it hits the ground? What equals 0? Y. So you substitute y equals 0 into this to get the time, and then you substitute the time into the x equation to get that distance, and then you minus it from, so sub y equals 0 into that. I'll continue here. I'll just finish this off quickly. Sub y is 0 into that, and we get 0 equals negative 5t squared plus 2 root 2t plus 52.5, making the a positive. So therefore t equals 2 root 2 plus or minus the square root of b squared would be 8 minus 4 times 5 times negative 52.5 over 2 times 5, which is which is 2 root 2 plus or minus the square root of 1058 over 10, which is t equals, all right, so we got that. That's our time. We're just going to use that. So, what are we going to do now? Girls, you need to see, I think if you do 2 root 2 minus, you get negative time, which is not possible. Therefore, t equals 2 root 2 plus the square root of 1058 over 10, as t is greater than 0. Substitute that into x, and if you sub that into x, you will get, it's the 5 root 2 t equation times t, which is 5 root 2 times all of that. Just do it on your calc. And you get that x is exactly 25 meters. So that's the rebound, girls. It rebounds back. That's 25. So girls, remember that was 75, the whole thing? So how far from him? That's 25. Therefore, the ball lands 75 minus 25, 50 meters from him. From Ji Ming. To finish this exercise, I will send scanned solutions. What I will do, I may do a very quick video talking over some of those answers if I feel that they're a little bit complicated.